All right, we're going to talk today about quadratic functions. You guys are all familiar with quadratics. Maybe you're not really sure how familiar you are. Okay, let n be a non-negative integer. Let a sub n and a sub n minus 1, right? Then none of this makes sense to you guys. I understand that. But what you need to understand is we are talking about polynomial functions. Poly means many, right? You're going to have many terms. And the degree of your polynomial is the highest exponent. So if you have f of x equals 6x to the third minus x to the fourth plus 7, right? This is a polynomial. It's got many terms. Is this written in standard form? No. How do you know it's not written in standard form? Because the highest exponent isn't first, right? So if you were asked what the degree of this polynomial was, this would be the fourth degree. The degree is 4. Now, I've talked to you guys about this before, and I'm going to say this so much, especially throughout chapter 2, because we are hitting algebra really hard in chapter 2. We're kind of getting away from the negative infinity to positive infinity, blah, 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 blah. We're going to really hit algebra. But the highest exponent of a function will tell you how many zeros you have. What does that mean? Zeros. X's. Where the graph crosses the x-axis. Now, we're going to get to some functions that have 4 zeros, 4 answers. You're going to factor it and find them. But some of them are imaginary. They're not real. All that means is it doesn't touch the x-axis, but they are zeros. They'll be like, plus or minus 2i, something like that. But you should always, always, always get that in your mind. Look at the highest exponent. When you are finding the zeros, however, whatever the highest exponent is going to be how many x answers you should have. Whether they be positive or negative, whether they be real or imaginary, that you should have that many answers. Does that make sense? On yesterday, one of the versions of the quiz, you guys, some of you had something like this. It said x squared equals 0, or maybe 3x squared equals 0. So you divide both sides by 3. You get x squared equals 0. You take the square root. Well, when you guys physically put the square root on, what goes in front of your answer? Plus or minus. Is there such a thing as plus or minus 0? No. So somebody asked me, like, I only got 1, but I should get 2. This is a special case. There really is 2 answers here. It's just that we don't have plus or minus 0. So if you just wrote 0, it's fine. If you wrote plus or minus 0, that's fine as well. And we'll talk about what that means when you have multiplicity and stuff like that. Getting way ahead of myself. Sorry. All right, what we're talking about today is just a quadratic function, okay? How do you know that something is a quadratic? Algebraically, when you look at it, what's the highest exponent? A 2. X squared, all right? You're going to write it in standard form where x squared is first, your b term is with the x, your constant is last. Does anybody remember the formula or know the name of the formula if you can't factor something and it's the highest exponent is 2? How do you figure out the answer to something? Use the what formula? The quadratic formula. All right, we are going to have to pull that back. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. We're not doing that right now. But if you are asked to factor or find the zeros and it's a quadratic and it doesn't factor pretty, the highest exponent is a 2. If it's a quadratic, you're going to have to use the quadratic formula. But again, we'll get to that later on. Quadratic function, highest exponent is 2. What is the shape of a quadratic function? What's the shape of a quadratic function? A parabola, right? Our shape of a quadratic function is a parabola. That is not pronounced parabola. It's a parabola. We're going to talk about positive parabolas and negative parabolas. I think it's on the next couple slides, but I'll look at it right now. This is a positive parabola, and this is a negative parabola. What is the difference of those two? The direction. One is going up. A positive parabola, guys, is happy. A negative parabola is what? Sad. How do you know if a parabola is positive or negative? God bless you. If you're just looking at the equation itself. Anybody know? God bless you. You look at x squared. If x squared is positive, which way is your parabola going? Up. If x squared is negative, which way is your parabola going? Down. Perfect. Okay, good. All right, then we're going to talk about some other things that have to do with a parabola, like the axis of symmetry. All right, the axis of symmetry. What does the word symmetry mean? The same on both sides. All right, axis of symmetry we're going to talk about, and something called the vertex. All right, your vertex is going to be the highest or lowest point of the parabola. And your axis of symmetry is a vertical line that does what, do you think, to the parabola? It cuts it in half. Good job. Cuts the parabola in half. Up and down. So your axis of symmetry, right? You have a parabola. Your parabola looks something like this. Here's my parabola, right? And here's my vertex. My axis of symmetry is going to be this vertical line that cuts the parabola in half. Is it an x equals or a y equals?
Y equals?
If this was graphed.
Oh, that's an x equals.
Yeah, that's an x equals. Good. It's always going to be an x equals. Okay, so now we look at this, and you guys are like, oh my gosh. All right, we're going to talk a little bit about the parent function. All right, when I say parent function, this graph right here is f of x equals x squared, right? Or negative x squared. Which one is the positive one? The one on the left? Which one is the negative one? The one on the right, okay? We're going to talk only about quadratics right now. So if I ever ask you what the domain, that's the x values of a parabola, what do you notice about the ends of a parabola? It's infinite, always. It's always, 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 always getting wider, always. So your domain for every single parabola that we ever talk about is what? Negative infinity to positive infinity. You guys need to remember that. If you're asked, what's the domain of this parabola? If you don't get anything else right, we need to know that it's negative infinity to positive infinity. Now we'll talk about range, how high it goes, how low it goes, that sort of a thing. But understand, you guys can tell range after you graph it. You can see exactly where it is. You don't even have to graph it if you know certain things about your parabola. And we'll talk more about this in real number terms in a minute. But if you guys are looking at a positive parabola, it's going to have a minimum point. What does the word minimum mean? Lowest, the least. There's going to be a point on a parabola that is positive. That is the absolute lowest. So conversely, if you have a negative parabola, you're going to have something called the maximum point. It's the highest that it goes. This point right here is called the vertex. It's either the bottom or the top of your parabola. That's your vertex. The minimum or maximum is the y value. So minimum and maximum, talk about y values. Your axis of symmetry is the x value. All has to do with the vertex. The vertex is the most important part of a parabola. We're going to talk a lot about the vertex. Yes, sir.
So you said the axis of symmetry is your x value?
Yep. We're going to say AOS is the x value in vertex. I can't spell. And your maximum or minimum is going to be the y value of the vertex. Your vertex tells you a lot about your parabola. You're going to be asked for the domain, the range, axis of symmetry, max and min, blah, 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 blah. 90% of it you can answer by just looking at your vertex. All right, you guys got it? Okay. All right, moving along. Basic characteristics. I just said all of this, guys. A positive parabola, right? A positive parabola over here on the left. It opens upwards, right? The vertex is the lowest point here. And this axis of symmetry cuts your parabola in half. This is a positive parabola. Over here on the left, it's a negative parabola. How do you know it's negative? Which way is it pointing? Down, right? So your negative is going to point downward. And it has a highest point. It has a maximum value because of how it's pointing. And the axis of symmetry still cuts it in half. So just think about a positive parabola. Think about in your mind, or do it with your hand. A positive parabola has a point that does not go any lower. It's your minimum. A negative parabola has a point that does not get any higher. That's your maximum. All right, so if you're asked to sketch a graph, how would you guys sketch a graph? If I just gave you this and said, hey, what does this look like? What do you guys now know what to do? How would you do this? Okay, it's negative. Good. I like your thinking. Very good, Alec. You're already thinking, okay, it's negative, it's going this way, it's going that way. You guys are already thinking about different transformations that are occurring, which is really good. On your test, if you had to graph doing your piecewise and you had a parabola, what did you do? You made a table of values, right? Well, gone are those days of our table of values. You guys don't have to do that anymore. We're going to identify things like the x-intercepts, the y-intercepts, the vertex. You're going to be able to tell things. But if I just look at this first equation, letter A, because this is negative, how do I know that my graph is facing, upwards or downwards? It's facing down. Okay, so we know that since x squared is negative, your parabola is facing which direction? It's facing down, good. So you can get a picture in your mind, okay, it's going downwards. And does anybody remember what this +1 at the end of a function means? What is it going to do to my parabola? It's going to move it where? Up 1. Perfect. Very good. So this is going to go up 1. So without actually making a table of values, you guys can get an idea of what this looks like. So if I asked you to graph, just a sketch, it just says sketch it. So you'd have a negative parabola that moved up 1, correct? So now you can say, oh, okay, I see. I kind of have an idea of what this looks like. Does this have a minimum point or a maximum point? Maximum. It's the highest that thing's going to go. God bless you. It's not going to go any higher. Okay, good. All right, let's look at the next one. First of all, what shape is this graph? B. It's a parabola. Why is it a parabola? A quadratic, because it's squared. Is this positive or negative? It's positive, so I know it's facing which direction? Up. Now there's two transformations happening in this one. Where is this moving? What does this tell me? Down 3 and where? Ooh, listen to you, kiddo. Left 2. Why did you say left? You're correct. Why is it left? There's a plus sign there. It's always the opposite. Anything inside the parenthesis with the x is opposite. So it looks like it would go right 2, but it's really like, whoops, it goes left 2. Anything inside. So if you were to make a sketch, I would say, okay, this is a positive parabola. It's going to go down 3 spots and left 2 spots. So it looks something like that. That make sense? Okay, good, good, good. We already talked about this 100 times. When we talk about parabolas, positive goes up, negative goes down. We just talked about this. You guys just told me. The shifting left and right, up and down. Okay. All right, so now we're going to talk about something called standard form. Now, the way that the book calls this, and you'll see it on WebAssign, they call this standard form. We don't call this standard form. On your test or a quiz, we're going to call this vertex form. To me, and to how we've always taught this and how I learned it and that sort of a thing, your standard form is ax squared plus bx plus c. That's your standard form to me. So understand on WebAssign, if they give you this function here and they say, give me the vertex form, or I'm sorry, if they say standard form, but it's written in vertex form or vice versa, understand that this is one form and this is another. I'm going to call them standard form when it's x squared x and constant, vertex form when it's like this. Your book and WebAssign doesn't differentiate. So just understand if it's in this form, they want you to go to the other one. If it's in this one, they want you to go to the other one. Okay, now we're going to talk about what all this means. You probably will remember some of this from Algebra 2, hopefully. But if not, no worries. In my mind, in Mrs. Meadows' mind, what kind of form is this? This is in standard form. Right? This is standard form. If they asked you to find the vertex, to find the lowest point, you can't just look at a parabola and say, okay, this is standard form. We're going to talk about vertex form here in a minute. But you can identify the vertex, and there is a tiny little formula that is so incredibly important. You guys are going to use it a lot. Okay, you ready for it? To find the x part of the vertex. X part of vertex. We're going to use this massively huge formula. Ready? X equals negative b over 2a. Does your hand hurt from writing that? To find the x part of the vertex, negative b over 2a. I'm sure you guys have seen this before. Now, you're like, okay, that's cool. What's a and b and all that? Do you already know what a is? What's a? A is 2. What's b? 8. So how do you find the vertex here? Well, let's find the x part first. I'm going to say negative 8 over 2 times 2. Now, guys, here's where you got to be really careful. If you mess up on this step, you forget a negative, you forget how to divide, something like that, the entire problem is wrong. So it's really important that you don't mess up little tiny math stuff here. So I'm going to write everything out. Negative 8 divided by 4. What's negative 8 divided by 4? Negative 2. So the x part of my vertex is negative 2. Well, if I know the x part, how in the world can I find the y? You plug it back in. Perfect. So to find the y, we're going to plug in. I'm going to say 2 times y equals 2 times negative 2 squared plus 8 times negative 2 plus 7. So let's go. What's negative 2 squared? 4. 4 times 2 is 8. Minus 16 plus 7. What's 8 minus 16? Negative 8 plus 7 is negative 1. So here's your vertex. Now, that told you a lot of information. How do you know a lot of stuff about this? Well, let's talk about it. What kind of a parabola is this? Positive or negative? Positive, so it's going upwards, right? So then you have determined that the vertex is right here at negative 2, negative 1, correct? Okay, so what's your axis of symmetry? What is this vertical line that's going to cut your parabola in half? It's at your AOS, your axis of symmetry, is at x equals negative 2. Perfect. All right, do you have a maximum or a minimum value here? You have a minimum value. Your minimum value is at the y part of the vertex. So you have a minimum at y equals what? Negative 1. Perfect. What's the domain of this parabola and every parabola we're ever going to talk about in your whole entire life? Negative infinity. Perfect. To positive infinity.
Do we have to put the x equals?
Yes, you have to have x equals and y equals. Don't just tell me random numbers. I need x. Axis of symmetry is x. Max and min is y. All right, so what else? What are some other things we could figure out? Range. Now this, for some reason, this always gets us. Range is based upon the y part of your axis because range is y, right? So this is how I like to think about it. If they ask you, what is the range of this parabola? Well, you have two options. Do you guys see this area here between the vertex and negative infinity? Yes, okay. And then do you see the area here between the vertex and positive infinity? Where does your graph exist? On the top part, right? So your range, we read range from bottom to top, correct? Your range starts at negative 1 and goes where? To infinity. If you want to think about it this way, if you have a positive parabola, your range is always y part of the vertex to infinity. If you have a negative parabola, it's always negative infinity to the y part of the vertex every single time. So we just determined so much just by finding the vertex. If I asked you guys where the x-intercepts were, how would you find the x-intercepts? What's another word for x-intercept? The zeros. How would I take this function and find the zeros? We set the y equal to what? 0, and we factor. If it doesn't factor, you use the quadratic formula. How would I look at this equation, ladies and gents? and find the y-intercept. Make all the x's 0. What's going to happen? What's your y-intercept, guys? 7. Your y-intercept is always the what? The constant, the c. You'd have to factor it. I don't think that factor's pretty, so you'd have to use quadratic formula. We'll talk about that later. Now, all the math, all the algebra that we had to do was this right here. Negative b over 2a, and then plug them back in. Everything else you can determine just by the vertex. Now, if you were given this, is what I call standard form. You're given this in standard form, and it says to write vertex form. Okay, well, look at the beauty of this. This is your vertex, right? Right here. Okay, so here is vertex form. F of x equals a times x minus h squared plus k. Well, the x and the y of your vertex are your h and your k in this formula. So if I know that my vertex is negative 2, negative 1, this is my h and my k. Do I know my a term, guys? What is it? A is 2. So can I now take this information and go from standard form to vertex form? Yes. What would my formula look like? F of x equals 2 times x minus a negative, so plus 2 squared, right? Minus 1. Perfect. And now you guys can go, oh, okay, this graph is going to move down 1, left 2. It's going to get a little wider because there's a 2 in front. All of that, guys, can be done by just finding the vertex. It's a super, super, super important piece of information. I just went over all of this. Negative b over 2a. We just went over all of this. Super. If it's, yeah, we went over. This is fantastic. Okay, so let's look at this. Given a point and a vertex, write the equation of the parabola in standard form. All right. On your WebAssign, they're going to say standard form. You'll see whether they want it in standard form, like Miss Meadow says, or vertex form. We'll put it up in a second here. But how could I do this? Let me do a different problem for a second. Let me just make something up. What about if I had f of x equals 3, no, I don't want to make up a problem because it may not work out pretty, and then I don't want to get into fractions and stuff right now. What about if I said my a was negative 3 and my vertex was 5, negative 1. All right, if you had that information and you were going to write in vertex form, you're going to write it in vertex form, what would your parabola equation look like? F of x equals what? Negative 3.
X
Minus 5, good, squared. And then what? Minus 1, all right? What are the two things you have to have in order to write your equation in vertex form? You have to have the a, and you have to have the vertex, okay? Deal. So how is this problem a tad bit different? They gave you a point, and they gave you the vertex. So what information do you have right now? You have your h and your k. You have your h, and you have your k. Agreed? Okay. I don't have a, though. How do you think we would figure that out?
use the x value from the b.
Could we use this point, kind of like we just did on our last test? On our last test, we were writing the equation of a line. Did we use the x and the y that was given to us to write the equation of the line? Right? We did that, right? You could do the exact same thing here, guys. This is just like writing the equation of a line. Instead of finding slope, we're finding the a term, which is basically your slope. It's your rate of change. So you're going to take this formula right here and plug in the information that you're given. F of x is a fancy way of saying what? So my y value is 3 equals, I don't know what a is yet, right? Okay, algebraically we're going to find it out. What is the x value that they gave us in the point? -7. And then I have minus h, so minus 4 squared, plus k, so then -1. All right, is everybody okay with what I just did there? If you're given a point and a vertex, you're just plugging all of that in, and you're going to simplify. Where do we start? What do I do first? The parentheses. So I have 3 equals a times -11 squared minus 1, right? Okay, what's -11 squared? So 3 equals 121a minus 1. Now what do? I'm going to add 1 to both sides. So I have 4 equals 121a. And now what? Divide by 121. Am I going to have you graph this? Absolutely not. So your a term, guys, you just found out, is 4 over 121. Okay. Weird fraction. Who cares? What are the two things you have to have in order to write your equation of your parabola? Your a and your vertex. Do I have both of those things now? Yes. So now can we write our equation? So f of x would be 4 over 121 times x minus 4 squared minus 1. So this is what we call vertex form. If I asked you to make this into standard form algebraically, how would you do it? You would just have to figure this out. You'd have to say, okay, f of x equals 4 over, don't write this down, x minus 4 times x minus 4 minus 1, right? You'd FOIL, then you distribute, then you combine like terms, and you'd end up with your x squared, x, and your constant. But you don't have to do that right now. Don't worry about that. All right, hang on 1 second. I want to just do this one thing real quick. You guys can just follow along and watch me. That's fine. All right, so say you had a parabola, and this probably won't work out real pretty, so just bear with me for a second. Okay, so say you had this, right? We know it's a parabola, yeah? And you were asked all of these questions. You were asked the direction that it opens. You were asked the axis of symmetry. You were asked the max and min. You were asked domain and range. X and Y intercepts. Domain, range, max, min. Oh, and vertex. Duh. All right. Look, you have a question like this. You might very well have a question on a quiz that's like this, and it asks you for all of this stuff, and you're like, OMG. All right. Let me show you how you can answer half of these questions without doing anything. First of all, what direction does this parabola open? How do you know it's up? Because it's positive. I would suggest that you guys go like this, draw yourself a little picture. Okay, I don't know the axis of symmetry yet, but I do know if I have a maximum or a minimum. I have a minimum. I have a minimum. I could say minimum. And I know it's going to be at y part of the vertex, right? So it's going to be at y equals. I know the axis of symmetry is going to be at x equals something. I know the domain of every single parabola you're ever going to talk about, and it's perfect, negative infinity to positive infinity. I also can kind of tell the range. Is the range going to be from negative infinity to the y part of the vertex? Or from the y part of the vertex to positive infinity? Y part of the vertex to positive infinity, because it's going upwards, good. X-intercepts. I can't just look at it and tell the x-intercepts, but can I just look at this function and tell the y-intercept? Where does this cross the y-axis? So my y-intercept is going to be at 0, 3. It's always the constant. Look, we have a lot of stuff answered without doing anything. So now we have to do a little bit of math. How do I find the vertex? Okay, x equals negative b over 2a. What's my b? So I have negative 7 over 2 times 2. Oops, going to do a little fraction. That's okay. You might get one. So I have negative 7 over 4. Agreed? Okay, so the x part of my vertex is negative 7 over 4. Where else can I put negative 7 over 4? At the AOS, right? Negative 7 over 4. Now, how do I find the y part of my vertex? I gotta plug that back in. Again, I'm sorry. I told you it probably wasn't gonna be great because I was just making this up off the top of my head, but work with me, work with me. Okay, so now we gotta do a little algebra. This 2 goes to the top and the bottom, right? So this is gonna be 2 times is 49 over 16. Yep. Then I have minus 49 over 4, right? Plus 3. You guys with me? Okay, so can I make this over 8 now? You guys all right with that? All right, now I need a common denominator, correct? My common denominator is going to be 8. So if I have to go through, how do I get my common denominator for 4 to become an 8? I have to multiply the top and bottom by 2. So if I multiply this by 2, 49 times 2 is? Good, 98. How do I get a common denominator? Here, I need this to be an 8, but it's a 1. So what would I multiply by? Okay, multiply bottom and top, so I get plus 24. Again, I top of my head, sorry for the numbers. So now I have 49 minus 98 is what? What was 49 times 2, guys? 98. So 49 minus 9, it's going to be negative 49 plus 24. So negative 49 plus 24 gives me what? Y'all are killing me. So negative 25 over 8. Okay, not great. Sorry. My bad. But what can we do with this? What do I know that this negative 25 over 8 is? It's the minimum, negative 25 over 8. It's also this part of my range, negative 25 over 8. It's also the y part of my vertex, negative 25 over 8. I hear it. So we have answered every single question. Victoria, can you just hit my phone, please? We've answered every single question. And the hardest part was you guys down here freaking out about getting a common denominator, right? We've answered every single question by looking at this function and by finding the vertex. Everybody see that? The last thing we're going to do is find the x-intercepts. How do you find the x-intercepts? You set y equal to what? 0. So I have 2x squared plus 7x plus 3 equals 0. Guys, what are we going to end up doing here? We're going to factor. Very good, Alyssa. So 2 times 3 is 6. What are the factors of 6 that multiply to give me 6 but add to give me 7? So multiply to give me 6, add, yes, x plus 6, x plus 1. Now my a term is not 1, so what do I do with it? I divide, right? I can divide both of them. So 6 divided by 2 is, and 1 divided by 2 isn't pretty, so this is going to come out here. 2x plus 1 equals 0. One more step. I said each one equal to. So x equals negative 3 and x equals negative 1/2. And we would write them as intercepts. So I have negative 3, 0, negative 1/2, 0. So you'll get a question like that, and you guys are going to be like, oh my gosh, it's so much. It's really not that much. The hardest thing you're going to have to do that you're going to get really annoyed with is you'll probably have a fraction, and you have to do a little math. You're going to have to math it up. But you can find so much information about a parabola just by looking at it, seeing if it's positive or negative, and then finding the vertex. Does that make sense?